Today we'll be starting with generators. Sorry, decorators. Okay. So, ఇబ్బంది అవుద్దా చూసే పెట్టుకోండి ఇంకో పర్లేదు పెట్టుకోండి ఇంకో లేకపోయిందో జరుగుతుంది లేదా ప్లేస్ మీకు సరిపోతుందా మీ ఇద్దరికి ఓకే సో decorators. If you look at the name itself, you can understand what decorators will do. So decorators will decorate the function. Okay. So as name suggests, they'll be decorating the function. Let's say we have one person with us, okay, or else let's say before keeping this in, before keeping all this furniture, it is just a room, okay, some normal room. Now after keeping furniture, like arranging whiteboards and keeping projectors, you can kind of converting this to office space. So we are basically room is same, there is no change in room, but we are decorating it with different items so that its purpose will be changed and its enhanced. The purpose will be enhanced. Similarly, decorators will decorate a function. We have seen functions so far, right? So decorators, they'll decorate a function. In the sense how decoration works here, they are used to add any additional functionality or to extend current functionality. Okay, let's say currently we have one program. We have seen this clinical details, right? Yesterday, the programs. In clinical details, we have this BMI calculator. That is one function. So the purpose of BMI calculator is it is kind of calculating the BMI and it's kind of giving the results, right? And also we have one more function wherein we have this analyze health and it is giving different parameters. So on top of them, we would like to display some common information for each and every patient. Some average statistics like average this age group to this age group will be kind of as per current lifestyle. These clinical parameters are changing in this way. Sort of, we need to display some common information. So instead of writing that information again in the function, we can kind of use this decorator. So what decorators will do, they'll be extending the current functionality of the function. Whatever task it is performing, they'll try to extend it or add some additional task to that. Okay, that's a simple thing. That's the whole work of decorator. But they are kind of some of the most useful things in help, like in regard with functions. Okay, as I said, they'll allow us to change or modify the behavior of a function without actually changing the function. Okay. Okay. So let me reshare my screen. So they'll allow us to modify or change the current behavior or add additional behavior without changing the function. We won't make any changes to the function. Or we have already written a function. We are not making any changes to that. We are just decorating it. Okay. So how decorators work? Okay. Decorators will always return a function. Okay, they won't return any value. They'll be always returning a function. And you know how function will return a function. You have already seen, right? This concept. Returning a function from function. We have already seen this, right? Okay. Let's say if you see here, this define decor of function. This is our decorator function. Okay. This decor is our decorator function. And this fun is our actual function. Okay, which we are decorating. This decor is a decorator function and fun is an actual function or actual function. Okay. Within this, we have one more function which is inner. This is basically a wrapper function. Okay. This is wrapper function. The reason which we are using wrapper function is we have one function with us. And using decorator, we are trying to extend its functionality. Right. And decorators will always return a function. So if you see this func here, let me take up highlighter. If you see func here, this is our original function on which we are decorating. So if decorator needs to return a function, like there should be some function inside that. If we are taking the same function and returning it again, there is no point in doing that because we are returning same function as is, right? So this inner function, what it is doing, you see here, result is equal to func. It is making function call to this func, right? And on top of the result which we have, it is kind of performing some additional operation. It is making some additional changes. Okay. If you see here, then it is this inner function is returning result into 2. Whichever result this function is giving us, it is providing us the like that result multiplied by 2 in this case. Okay. And this is return inner. So this return is for outer function. You have seen, right, nested functions, and this inner is for inner function. Okay. And if you see here, this is my actual function, which is num. And what number is doing? It is just returning me 5. Okay, it is just returning me 5. It's doing nothing else. Okay. And if you see here, func is equal to decor of num. I'm calling func is equal to decor of num. So I'm calling decorator function and I'm passing my function to this. So, and if the result will be a function because decorators will return us function. And if I call this function again, what this will be doing, this number 5 will return me 5 and decor function, what it is doing, on top of that 5, it is multiplying it with 2 and the result is 10. Clear, right? Inner function, within this decorator, inner function will take this function on which we are decorating and it will perform additional logic. See, if you see this FUNC, this is nothing but our number function. Okay. This number function we are passing to decorator. In decorator, we are passing for this func, I am passing num function. So it will just execute the num function and result will be 5. And 5 will be assigned to this result variable. Okay. And result into 2. It will take 5 and multiply it with 2 and it will result me 10. Clear, right? So you might be thinking that what is special because we have already covered this nested functions and a function can return other function. So the real uses here, let me open this notebook and let's write some program here. I have my function which is decor కనపడు ఒకసారి ఆన్ చేసి పెట్టేది ఆన్ అయ్యే వరకు ఓకే ఇబ్బంది పడతారు లేదు ఓకే అది జాయిన్ అవ్వదు అదొక నేను కోడ్ రాస్తాను. So this is my decor function and within this I have one more function which is inner. Okay. In inner, what I am doing, I am just calling the my function which I need to decorate, which is func in this case, and I am returning result into 4. Okay. And this outer function's return will be inner function. Okay, return inner. So this is my function now. Okay. And I have defined num and it will just return some, let's say 7. Decor of num. So if you see what I have did here, I have taken decor function, which is my outer function. So I have taken my outer function, which is decor. It is my decorator function, and we have wrapper function inside. Okay, and wrapper function is just calling my function which I am passing to decorator, and it is kind of just multiplying it with 4. Whatever this function is returning, it is multiplying that value with 4 and it is giving me inner function. Okay. And if you see here, this is my function and I am passing this function to decor and the result will be assigned to func. And when I call func, it is 28 because number is returning 7 and return of 7 will be my sorry, 4 into 7 will be my 28 result. Okay. If I'm calling number 7 now, if you see result is 7, right? So the real power of decorator comes here. Okay. Let me do here this operation. So I have just did at decor. I haven't done anything. I'm just doing the at decor. And if I execute this again, if you can see, have just called my function. Okay, I haven't passed it to decor or I haven't performed all these sorts of operation. This is my function, and I have performed this at decor here, and I'm kind of what do you say calling the function which is my num, and it is giving me result of 28. Okay, so what's happening here? This art decor is Python's convention for decorator. Okay. If I'm calling art and I'm giving it function name before my function definition, this indicates this number function is preceded by decorator. Okay. So this we have some decorator function which is extending our current functions functionality. So you need to make sure that you'll be using this decorator function. You will pass this function into this decorator and accordingly you will modify this function's behavior. So this function alone will do just it will return 7. When I'm decorating with my square of number, sorry, with this decorator function, it is taking the number 7 and multiplying it with 28. So now this decorator changed this function's behavior itself, right? Before decoration, it's giving only 7. Now it's giving 28. We have added additional functionality to multiply the result with 4. Okay, this is the real use of decorators. Okay, clear, right? What decorators will do. So now you can, it's making sense, right? Why we have this inner function, outer function, why function returns function. Clear, right? You have wrote some program trying to implement this logic. So this is the real usage of this nested functioning. Okay. Same thing. Whatever I have explained that this is thing. We can just use at and we can give this decorator function name and the is it will do same job for us. Okay. If you see other function, this is one more function. If you see this is my decor function and I have inner function. Okay. And result is this one. I'm calling this function with variable. I'm passing some argument and I'm assigning the result to this result variable. And after getting result, what I'm doing, I'm just concatenating the result which I'm getting with how are you. Okay, now this decorator function I'm calling on this hello function. Here I have this decor, right? Define hello of name. It's returning hello plus name, right? What it's doing, this function will take a name and return a message hello plus name, whichever name we are passing. Since we have decorator here, we are doing some additional step here. So this function is printing hello name, whichever name we are giving. But this decorator, it's again to the greeting which this hello function given. It is again adding how are you message. And my function result here will be hello Mahi, how are you? Okay. So let's take a function into idea and let's see how it works over there. Okay. Okay. If you see here in this case, this can be any name. It's not like we need to give only these names. You can give any type of name here. Okay. I can give decorate message. Okay. Decor message. I'm just decorating my message. Okay. Whatever decorator name here I'm giving here, I should make I like we should make sure we are giving same name while decorating the function. And even this can be anything. It's not need to be inner. You can give any thing here like add.
Narrow function also as a decker with the
Yeah, yeah. Any function, but always remember decorator should return a function to us. Fa- just remember the functionality of decoration. It is taking some function and adding some extra functionality or changing its current functionality. In the sense, this should be the decorator syntax always. Okay, this should be decorator syntax. Okay, if any function which we have in this format, we can like whatever function we are trying to build, which we need to use as decorator, which we need to use as decorator, that should return as a function. This function should contain some wrapper function, which will be some inner function. Inner function will make call and it will perform additional operations on top of the result given by current function. And it is kind of taking result and it will give us the result. Okay. So this is treated as a function or this one, this FE1C. That is in function definition, you can pass anything as argument. You can pass any data type as argument. You can pass integers, you can pass tuples, list, you can pass functions itself as argument. Anything which is passed in the function definition is an argument. Okay. You can pass anything over there. Literally, you can pass class as well. We'll be covering class and objects, right? You can pass those classes as well here. Anything we can pass here. Okay. So now coming to my inner function, like main function, I'm just taking a name and I'm just calling it, saying that I'm just taking name and I'm returning hello and name. Okay. And if I'm executing this function now, you can see hello Mahi, how are you? The reason being this decorator is taking the return given by this hello function here and it is adding some extra information, which is how are you? Okay. Clear, right? So within function, you can take any sort of things. Okay. The decorator syntax will be same. This is how we'll construct a decorator and we'll use it. Okay. And if I am kind of seeing here, I have this help, right? Hello. This hello is my function, right? Dot. This is some inbuilt function which we'll use to check the function name. Okay. What is the function name for this hello? Okay. If you see this hello name, it is giving me add extra message. So it is treating this function as add extra message. Okay. But actually, in reality, our function name is hello. But here it is giving us add extra message. The reason being, this is the wrapper function, which we are using to decorate the original function. And it's all together taking this function's name. This is just taking the function's name and it's kind of overwriting it. It is completely uh, vanishing. Like this function is completely vanished now. So to avoid this, what we can do is we have one library from func tools. We have this wraps, okay, from func tools wraps, and how we can call this itself is a decorator, okay. Wraps of func. This wraps itself is a decorator using which we are kind of decorating this. If you see now, I'll be getting my function name as hello. The reason being this is my actual function name. Before giving, if I'm not giving this wraps here, my function name will be add extra message. But this is not my function name. This is kind of wrapper. My function name, actual function name is this, right? So if we use this wraps of func, it will kind of override this behavior of decorator and it will return us the actual function name on which we are calling this decorator. Okay. So if you see here, this is you already know about help, right? If you give help of function, we'll get functions, docstring, everything. You know about docstring as well, like what function will do its description, what input it take, what output it gives. So if you see here, I'm trying to access the help and hello function. You see here, It is giving me add extra message of n, and within that it's giving some wraps of func. So this is not what which I wanted, right? So it will kind of restore the original functions properties, in the sense original functions attributes like function name and the functionality other things. Okay, this is the wraps function. Always try to use this thing. This is kind of good practice when we are using decorators. Try to use a wraps function always. Okay, this is same which I have explained. So decorators will hide the function they are decorating. So they will be hiding the function which they are decorating. They won't let others know that which function they are decorating. So to avoid this, we can use wraps. As I showed, we are using wraps and uncovering the original function which we are decorating. Okay. So same thing. This will update the decorators with the functions attributes. Okay. It will restore the original functions attributes there. Okay. And decorated chaining. So we have seen one decorator, right? It's not like we need to use only one decorator. We can use as many decorators as needed. Can use any number of decorators before a function. So it will apply all those decorators to the current function. Okay. If you see here, this is my first decorator, which is half. So basically, this will just take the function's input, function's result, and it will divide it by 2. Okay. And this is my second decorator, which will kind of take the result of function and it will square that result. Okay, these are my two decorators now. Let's see how we can decorate function with two decorators. Okay, so these are my two functions which are half and square, and I'm decorating them with one is square, one is half. Before this, my original function is define num, and it is just returning me a value of 10. Okay, and what I'm doing now, I'm just decorating them. Okay, I'm decorating them with my two functions. Okay, so now this is my function and I'm decorating them with two decorators, and I'm just calling this num now. Okay, just guess what will be the result of this operation. I'm calling number here. Just check what happens here and just try to guess what happens here. This function will kind of take the result and half it. Okay, it will divide it by 2, and this function will kind of square the result. And I'm kind of applying both decorators to my number function. Print 5 on 25. You said it will print 5 100, right? Okay. So let's see the result. Okay. The decorators here, they'll be working from top to bottom. Okay. Let me, something is wrong here. I think it's expecting some input. Okay. So it's giving us result of 50. Okay. What's happening here is, if you see the function, this is my function. This is my one decorator and this is my second decorator. So decorators will always work from top to bottom. If you are making chain of decorators, they'll be executed from, sorry, my bad, bottom to top. They'll execute it from bottom to top. We have one function. On top of this function, we have square. So this square will be first applied to this function. Okay. This square will be first applied. This half will be second applied, and so on. We have function. Just remember step by step. From bottom to top, it will be kind of applying decorators. So in this case, we are giving number 10. So it will first square it, which will be a 100. and it is on the result. Now we have this 100 result. Again, this square function, we are decorating it with half. So the result of this 100 will be passed to this half decorator, and it will just divided it by 2, which will be like result, which is 50. Okay. Now, if I am doing same thing, I'm basically doing same thing, but I'm just switching the order. I'm first taking my, like taking square as first one and half as second one here. Okay. If you see the output now this will be inverted. The reason being, we are giving 10. First, it will half it, which will be 5, and it will square it. You can add any number of decorators. You can have some cube over here, okay, and you can have some square root over here. You can perform any sort of operation, any number of decorators. They'll be working from bottom to top. Clear? This is decorated chaining, okay? So, 430 కదా. So I think these are the decorators, okay? And there is one more simple concept, which is generators. Okay. So far, you have seen this range function. How range is working, you might have came across this range function, right? During my examples. For I in range of 1, comma 10. Okay. Print of I, comma end is equal to this one. So this range function here is a generator. Okay. This range function here is a generator. They will return sequence of values. Okay. Our normal function will return a single value. It will return all result at once. When we are defining a function, if it is encountering return, that is the end of that function. After the return statement, if you are even if you are giving some hundreds of code, those will be not executed. Whenever the return is encountered by a function, that will be the final step of that function. The function won't proceed further. In case of generators, even though just be clear here, function will can return sequence of values also, but it is returning at once. It is returning at once. But generators, they'll be giving us generates. Okay, they'll be generating the values. Okay, they'll be returning us sequences or iterables. They'll return us iterable on which we can iterate. Clear, right? On which we can iterate. Let's see. Let me explain it clearly. So this is my range function. As you know, in my Python range function, it won't consider my end index, right? If I'm giving range of 1 to 10, it will give me only 1 to 9. So for some reason, I don't want to use that. I don't want to use my range function, which is inbuilt, and I wanted a range function which will consider both lower and upper limits. So now I'm defining this to be custom range. Okay. Custom range, low, comma, high. So this is my function, which is custom range function. Okay. I'm not using my inbuilt range, and I'm defining one custom range function, which I'm customizing as per my requirement. Now what this function will do, okay. Or else it will take while no, we need to take one initializer which will be low. Okay. My initializer here is low, and I'm taking while I less than or equal to high. Okay. While high less than or equal to high. Or else you can also remove this. If you are comfortable, you can just have this while low less than or equal to high, just yield low. Okay, yield low. My low now will be low plus or equal to 1. Clear, right? Now, if you see here, this is one keyword which is different, right? This yield is kind of bit different now. Clear, right? So this is the main difference between normal function and generator. So return will return the value. If you are asking something, function will just give it to us, just take it. But what yield will do, this generators will do, they'll keep on giving us values. If you ask it for something, here we can ask for set of outputs and it will keep on giving us one by one. Okay, let's say we have taken a function which will give us gross, like which we have created, and we are passing money and items to this. And we are asking this function to perform a task which is shopping task. It need to use that money and items list which we are giving, and it need to purchase all those items to us. Okay, so what function will do, it will take money. It will kind of function in this case is our child. Okay, we are asking our child to visit a supermarket with money and item list and bring us the these things, what you say, groceries. So he'll bring them and he'll give us, okay, this is your money, this is your item list, take all your groceries. That is the traditional functionality. So in generators, the behavior of child will be like, he'll be bringing items with the money and item list which we have given. But he won't give us all items at once. He'll give items one by one. First, I have to shop at this one, take this. This is my second item, this is my third item. There, right? So functions will always return values at once. This generator, they'll be yielding. You know, yield, right? They'll be yielding values in the sense they'll be generating. We can iterate through that result. Okay. You see here, my custom range function, while low less than or equal to high, I'm just incrementing it and I'm kind of giving yield of low, right? And sorry for this. I think it should come here. Okay, now I have my custom range of 1 comma 10, right? You see here, when I'm calling this function, I don't have return, right? I have yield here. If you see here, custom range, I have just called it. I haven't assigned it to any result. So ideally, if it is a return here, it will just return me a value. But this is a generator. I'm yielding the value. If you see here, the output is generator object custom range. So it is, see, due to this yield keyword, it is returning us generator object. Okay, generator. Since it is returning us generator object, this function is called a generator. Okay, generators are nothing but functions which return generator object. So now, if I do same thing on this for I in custom range of 1 to 10, I'm doing the same thing. Print of I comma end is equal to this. So if you see now, this is my original range. You see, this is my custom range, right? For I in custom range of 1 comma 10, print of I. So it is, I have just written my function, custom range function, which will consider my higher bound as well. And it is kind of returning me this range. Now I can kind of start using my custom range. Instead of bothering that this range will return only this and I need to always kind of increment it, I can just write my custom range function. I can make use of that in my code wherever I want it. Is that right? So if you see here, even this is kind of, I'm doing same thing here. I'm just using range here. I'm using custom range. You can't notice the difference here. So now real difference here is, let me give it to result of custom range of 5. Okay, 1 comma 5. So I have taken custom range and I have assigned it to result, right? Now if I'm printing result, it will give me generator object. Won't give any result. Okay. In Python, we have one method called next. Okay. What next will do? next will give the next value of a generator, okay, or iterator. You see, uh, here next of result, okay. You see here, first it has given me 1, 2, 3, 4, and 5, and it will throw error saying that stop iteration. So my result value is a generator object which is holding values from 1 to 5, and I can iterate through that using this next. Since there are no items left now, it is giving me stop iterator. Okay. Now just observe this again, and I'm giving next again. It will print 1 to 5. 1, 2, 3, 4, 5. So we know it has only 5 items. Generator has only 5 items in it. If I try to access any other items, it won't have, because generator it already generated and it is giving us. It has just given us the number. So it is no more in that generator. When we have used first next, generator has given 1 and it has only 2, 3, 4, 5. When we are using next again on the same generator object, it will give us 2. Then now we have 3, 4, 5. Again, when I give next, it has given me 3. Then I have 4 and 5. Clear, right? And at last, it has only 5. When I give next, it gave me 5. And now there are no items left in the generator because this function has given only 5 items to this. Now this will throw error saying stop iteration. In the sense, these are the only items which I have with me, and there are no more items with me. So clear, right? Functions will return a single value. Generators will return generator object. And using generator object, what we can do, we can kind of perform this next operation. It will keep on generating one value at once. Okay. Once we have used the generator, it won't exist anymore. Let me show that as well. And I have this result with me, right? Let me for I in result print of I. Now this won't return anything. The reason being, after performing this operation, and I have called this operation. So I have got 1 to 5, right? Yep, ma'am. Class on sound. So this is my result, which is generator object. I am accessing all items of this generator, right? Now, if I try to do next of result, it will throw error saying that stop iteration. So whatever result, like whatever generator object, this generator function has given me, if I am using it once, I'll be like the generator won't be like it won't hold any values. Okay. We can only access the generator items only once. We can't access it more than once. Okay. But in case of function, if we have a result, we can use that result any number of times. But here, since I have used this, accessed this result generator and printed them, it's kind of giving stop iteration. Now, if I am doing this again, and if I'm taking next of result, I have this next of result. I have accessed my, okay, let me tell in this way. This will make even clear. So now I have my result, which is holding 1 to 5 values. Next of result gave me first value. You see the output here, it's giving only 235. The reason being, the first value is already accessed by this next method. And it's holding only 235 now. Result is holding only 235. Okay. Now I have again executed this function and I have this result with me now. And let me do one more thing. I am just breaking this. Okay, here. Now if I take next of result, I have 1 and I have access to 2 as well. Now if I 3 here, I have 3 now, right? Now if I access it again, it will give me 4. If I access it again, it will give me 5. If I access it again, it will show error saying that stop. Okay, sorry, it won't print anything. The reason being we are accessing it. So once the generator object is created, we can access only once. We can access the generator object's contents only once. After this, the generator will be vanished. Clear, right? So basically, this is the decorators and generators. Okay. So we have keywords and modules, and let me cover keywords as well. So modules is kind of bit advanced one. I can show you the uses of this. Okay, in PyCharm. We can see that only in PyCharm. Okay. So Python, as I said, we have some built-in keywords. This print, input, sum, and we have this range, and we have this what do you say? There are many functions, right? Pass, break, continue. So all those are Python's built-in keywords. So we can't use those keywords as variable names. So if you are not clear, like what are all the keywords available and how I can kind of avoid using those keywords. Okay. So there are two ways. One is Python will automatically highlight the keyword using this color for if, else. Okay. If you want to check all the keywords available in Python, you just need to import this keyword library. Okay. This is a keyword library. In this keyword library, we have these two methods. So this keyword dot kw list give us all the keywords available in Python. Okay. This is the list of items available in Python. Okay. List of keywords available in Python, which we can't use as variable names. If we are using them as variable names, they will kind of overwrite our existing functionality. Okay. Now, if I see here, then I'm just checking the length, means how many keywords we have per in. So currently we have 35 keywords as of Python version 3.9 with us. So you can use these keywords. So if you need to check if any keyword like if any word is present in keyword, then we can use this method. Just give me is keyword. Okay, I just forgot the name. Can you just use is keyword and you can give some keyword here. Okay. I need to give it in string. Okay. So in is a keyword. Now this ins is a not keyword. So it will give me false. So what it is doing here, it is just taking the word and it is checking if word in list. If word in list, print true. If word not in list, print false. But simple if else, it's kind of just doing simple if else and giving us a result saying that it's keyword or not. So just be careful. We should never use this keyword as our argument. Okay, sorry, variable. Let's say we have this false with us, and I am assigning false to some two. Okay, before doing this operation, let me do if false print inside if else print inside else. So now this will give me result inside else. The reason being if false. False is nothing but false. If condition is false, then it will enter into this if loop. Only if condition is true, then it sorry. If condition is true, only then it will enter into if loop. Condition is false, it will go to else loop, right? Now, if you see here, I have done this assignment. False is equal to 2. Okay. So I think it's throwing some error saying that cannot assign to false. Okay. So basically we have this sum, right? Sum of 1 comma 2 comma 3 comma 4. This is internal sum method and it's kind of giving us some 1 2 3 4. I'm just giving define sum of ls. return. So now what I'm doing, let's say I have accidentally wrote one more function which is sum, and it is kind of returning a list of square. Okay. Now if I'm doing this sum again, if I'm executing this sum again, you can see now I'm getting 2468. The reason being it is returning me the not square into 2. It is multiplying each and every item in this with 2, and it is kind of giving me the result. So this internal function is sum, which is kind of sums the items in the sequence. But I have accidentally wrote function with the same name. Now this function is overwriting my internal sums behavior. Clear, right? So that's why we should never use these keywords as our arguments or as our variable names or as our function names. Okay. So those are the keywords. So for next class, we'll cover modules, which is kind of bit advanced, like how we can use one module in other work. Let's say we have written one function, one script, which is kind of doing some sort of activities. And we have one more script which needs these activities from this script. I have one script with me and I have one more script with me, two scripts. So second script wanted to use methods from the first script. Clear, right? So we can kind of import this as a package into the second this thing. Instead of writing the function again in the other script, you can kind of import it. You can store it anywhere in your project. You can kind of just import and use those methods again in the functions where we are importing it. So I'll show how to create packages like and how to do this. Okay, and then we'll be covering with this like we'll end this what do you say we'll start with this object oriented programming. So after we are done with modules, we'll be starting our object oops concepts, okay, where we'll encounter these classes and oops methods, encapsulation, this inheritance, abstraction, these things, okay. So this is it for today. So just to revisit, మొత్తం అంత కూడా అంతా పంపిస్తా చెప్పా కదా, అది కొంచెము డెకరేట్ మొత్తం అంతా నీట్ గా ఒక HTML డాక్యుమెంట్ లాగా చేసి ఇస్తాను. మీరు జస్ట్ బ్రౌజర్ లో ఓపెన్ చేసుకుని చదువుకోవచ్చు. అది కొంచెం టైం పడుతుంది, చేసిస్తాను నేను అది. ఓకే, ఇప్పుడు అలాగే ఇస్తే మీకేం అర్థం అవ్వదు. అది నేను మొత్తం టెక్స్ట్ అంతా యాడ్ చేసి ఏ కమాండ్ ఏం చేస్తుంది, ఏ కాన్సెప్ట్ ఎక్కడ ఏముంది అన్ని నోట్స్ రాసి ఇస్తాను. ఎప్పటికైనా వాడుకోవచ్చు మీరు. అది నోట్బుక్ ఇస్తా, HTML ఇస్తా. నోట్బుక్ అయితే రన్ చేసుకోండి, HTML అయితే నార్మల్ మొబైల్లో కూడా చదువుకోవచ్చు మీరు క్లియర్ గా. అది ఓకే. సో క్లియర్ కదా, డెకరేటర్స్, జనరేటర్స్, కీవర్డ్స్ కవర్ చేసాం. క్లియర్ కదా, ఏమైనా డౌట్స్ ఉన్నాయి ఈరోజు క్లాస్ లో?